All right, this is the second page to Unit 7 morning review. Page 1 and 2 is done already, and we are on page 3. All right, so as I was saying, we know area formula, but we've not seen it given in this form. This right here, guys, will require you to just remember not only prior lessons from this year, but from last year and even the year before. So, let's write down what we have. Side A is what? 10. What else do we have? Angle A is 40, and what else do we have? Side C is also 10. Okay, do you guys remember the two formulas that we have to choose from? I'll write them down over here, and then we can decide which one we want to use. Okay. One of them is area equals 1/2. I'm just going to write down one of them. AC, don't forget it's the sine of B. I'm not sure if this is the one I'm going to use. It might be BC sine A, or whatever other options there are. But remember, if you're using sine B, then you're using sides A and C. Do you guys remember the formula? Yes or no? All right, the other one is the big square root one, S times S minus, I'm going to make that a lowercase a, S minus A. And what's in the next two parentheses? S minus B, and the last one? S minus C. Okay, where S is the partial sum. You add the three sides and divide by 2. Okay, any thoughts on which one we want to use? The first one? Okay, so tell me why you're saying the first one.
So C is equal to angle A because of the fact that the two sides are the same number, and then we just find angle B, and then we have all the things we need for number 1.
Did everyone hear that? Okay, she said if you don't want to do extra work and have to find like extra sides or anything like that, she said she knows that this angle is 40. She told us why. Who can tell us why? What did she say on why this was 40? Janelle, can you tell us why that angle there is 40? No Z. It's a what? Not equilateral, isosceles. Isosceles because those two legs are the same, which means base angles are the same. You learned that in Math 2 first semester. Okay, I do not know why that turned off. Okay. So she said add and subtract from 180. 40 and 40 is 80, so what is this top angle? Now, do you have enough to use this formula? I know two sides, and I know it's sandwiched angle. Yes or no?
Yes.
All right, so it's sine B, so it actually is the right one. And we go through and we plug it in. A equals 1/2. A is 10. C is 10 times sine of angle B, which is 100. All right, go ahead and plug that in your calculator. If you didn't pick up a scientific calculator, make sure you have one now. you guys plug it in and do you have an answer? All right. Starts with the 4. 49.240. And it didn't give us units, so I'm just going to put units squared, or you can write out square units. All right. Does anybody feel like I would most likely choose this one, or what do I do if I forget that one? Can you still use this one if you wanted to?
Yeah, that's more work.
It is more work. She is correct. Yes, you can use this one, but it is more work. I'm just going to at least show you some of it so you can see. In order to do this one, you need all 3 sides. Do you agree? And what side am I missing? B. I can use law of sines here. Can you see that? I'm going to do sine of 40 over 10 equals sine of 100 over B. Can you guys write that and plug it in your calculators and see what you get for side B? Hello, Mrs. Torres. Yes, he is. Bye-bye. All right, so plug that in. I have sine of 40 over 10 equals sine of 100 over B. Find side B. And again, as she stated earlier, this one does require more work. I would suggest the other one. Anybody have side B yet? Nobody? Starts with the 15.321. Okay, and then after you find B, what would you have to find next in order to use this formula? S, where you add up the 3 sides, 10 plus 10 plus 15.321, bless you, divided by 2 or 3? 2, partial sum. It's not the average. You divide by 2. And then you have to find S, 17.661, and then you would have to plug it in here. And I believe when you plug it in, the decimal may be off just a smidge at the end, but I accommodate for that on the test when I'm grading. I have both methods worked out, and I look to see the method you used and what your answer should come out to be. Which way would you say is the easier way? The first one or the second one? In order to use the first, do you have to recognize that it's a side angle side and it's the sine formula? Yes.
Is there also going to be a time when we have to use the circuit one?
Good question. Let's try the next area formula. Find the area, and what did they give you? All sides. Did they give you an angle at all? Now, technically, if you wanted to, could you use law of cosines to find any one of your angles? Yes, and then you can use this you could use this formula if you wanted to. But since they gave you all 3 sides, is it easier to just use this one here? Yes? Yeah, it's easier for this one here if they give you all 3 sides to do 29 plus 14 plus 17 divide by 2. Go ahead and do that now. That's what the formula for S is. It's the partial sum. It's not the average. If you look in our notes, S is just the partial sum. So it's the sum cut in half. Whatever the sum is of the 3 sides, but always cut in half. It's 60. So area equals square root 60. Oh, I didn't divide by 2? Oh, thank you. It's okay. Which makes sense when you look at what it is. Okay. 30, and then 30 minus 29, and then 30 minus 14, and then 30 minus 17. How you plug that in is up to you. You can plug it in exactly like you see it, big square root, and then type all that in. Or you can do all the 30 minuses first. Totally up to you. Please plug it in now. I should see everybody touching their calculator. All right, do you guys have it? Anyone? 78.994, and this one has meters, so meters squared. Does anyone want to see it using this formula up here? No, we're okay? Okay. Questions before we move on to the word problems? Okay. A parallelogram with sides 20, 35, and 40. Find the larger angle in the parallelogram. Okay, so we've done this one a few times. Remember what I've said about angles? Let me draw the picture first. 20, 35, and a diagonal of 40. Okay. Can I find, I'm just going to label this ABC. Do I have enough right now to find angle B? Yes or no? Yes? I'll put a theta there. Do I have enough to find angle B? Yes. If I'm looking for angle B, that means my formula is going to start off with what? B squared equals A squared plus C squared minus 2 what? AC times cosine of B. Is this one where I have to rewrite or do not have to rewrite? It's a rewrite? Okay, so I'm going to have B squared minus A squared minus C squared. What do I do next? Add or divide? Divide by negative 2AC equals cosine of B. Don't forget to put your parentheses in. Cosine of B equals, what is B in this picture? What side is B? And it is important to know that. What is it? 40, because it's opposite angle B. So 40 squared, take away which one is A? 35 squared. Take away which one is C? 20 squared, divided by parentheses negative 2 times A times C. All right, go ahead and plug that in. Second cosine, second answer at the end. Did you plug it in already, Ryan? What was that? Okay, I'll give everyone else a chance to plug it in. All right, Ryan, can you tell us what you got? I'm going to put theta in here only because that's what I called it.
I got 0.017.
Theta equals, did you do second cosine, second answer yet?
No.
Okay, don't forget.
I do have that though.
Okay, what did you get
I
then?
got 88.976 degrees.
88.977?
6.
What's after the 6?
Oh, I don't have the full thing. I just have the 3 digits. So I have the 87.976 degrees.
When you plugged it in your calculator, do you still have the number in your calculator? No?
It's
No,
0.9768.
I did a long time ago. But I did it this weekend.
Oh, okay, I see.
It's 977.
It'll be 77. Just be careful. I'm going to show you the number really quick. So he did this ahead of time, which is perfectly fine. He did it over the weekend. You want to be careful with your with the rounding, 977, and be careful. Remember, you don't round this number up here. It's okay if you write it on your paper with just a few terms, a few digits, but when you plug it in your calculator, you leave the big number in there, and then do second cosine, second answer. Got it? Okay. Now, what's a mistake kids will make? They're like, oh, answer, and I'm done. What did they ask us for? Now, because of the way I drew it, you may say, oh, that's the larger. Well, I didn't draw it to scale, so we don't know that that's the larger. And a mistake kids are still making, even though I've told you guys not to, they say, oh, well, these two angles are equal, or these angles are cut in half, and they're not. Should I do anything with these little tiny angles here? No, no, and no. They'll find that little angle and then double it. That's not what happens with all parallelograms. Okay, so I've done this with you before. If we have this, this is 20, this is 35, and we just found angle B to be 88.977 degrees. Do we have enough to find the other angle? What's this angle over here, by the way? 88.977. Do we have enough to find these two?
Yes.
Yes. I've given you two different methods. Who can tell me one of them? Yes. Subtract it from 180, because these two angles are supplementary, or those two angles are supplementary. Any of these two consecutive angles are supplementary. So she said subtract it from 180. What's the other way? Add these two and subtract it from 360. And then why do we cut in half? Because these two are the same. They're equal. All right, do that now, whatever method you use. All right, what do we get? 2, 3 degrees. Okay, and it asked us for the larger or smaller? Okay, so I have both of them in my work, but let's say this was a test question and here's my blank. I'm going to fill in the blank. Do I write both of them down? No, you'd get it wrong if you write both of them down. Which one would I put down? The larger one, 91.023 degrees. Now, it might be the first answer. You may not know it until after you subtract, but you do need to find both of them first to determine which one is the larger one. Does that make sense? All right. Questions? You guys can all do this one on your own on the test. Okay. All right, next one. On a walk, Mrs. Rents travels south 40 degrees east, 30 paces, and then 45 paces north, 15 degrees east. How far is she from her starting point? This is probably one of the harder ones that kids struggle with on the test. There's the starting point. Would you guys like a few seconds to see if you can draw some of it on your own? Okay, I'm going to give you guys a few seconds to see. Brian, did you do this one ahead of time as well?
Yeah, I think that's right.
What did you get?
The full answer?
Yeah.
I got 20.490 pages.
Can I see your picture? I'm just wondering what the picture looks like. All right, so go ahead, guys. Try to draw your picture. Did anyone else work on it over the weekend and get it done with? Okay. Can you tell me where your starting point is at? This is your start. Okay, so the 40 would go here because it's south, 40 degrees east from the south line. So I think you just have your angle on the wrong spot. Yes.
It's 15. Does it go out there or in there?
Inside.
Inside.
Is it 15 degrees? Yeah, it goes inside, but it goes not inside the whole angle. It goes from the north line. So it'll be right like that little tiny piece.
Okay.
All right. Are we ready? Okay. So Mrs. Rents travels south 40 degrees east 30 paces. Okay, so from my starting point, I'm going to draw my south line. Does she walk directly south? No, she goes which direction? South, east. Now, would you agree from my south line, southeast would swing this way? Okay. And what's the degree between my south line and the actual path that she took? 40 degrees. And how many paces did she walk? 30. Okay. Does she stop here and then go straight back home? No. She then walks 45 paces going north 15 degrees east from this new point. So this is her start. She ended here, and then she turned herself north. And from the north line, which degree does she turn?
15.
In which way? To the right or left?
No.
This way?
Right.
Okay, so 15 degrees is right in here. And how many paces?
3.
Okay, so can you see, here's where she starts. She walks southeast. Do you agree from starting point, if this is north, south, west, and east, that this direction here would be southeast? Yes? Southeast, 30 paces. And then from here, she goes northeast. From here, would you agree that's the northeast direction? Yes. Did anybody's picture look close? No? Okay. What I would suggest is the same thing I did suggest with that the fire station type fire tower problem. Cover it, try it on your own, and keep trying it on your own until you can replicate that image, because you will see this on the test. Okay, how far is she from her starting point? So here's where she started, here's where she ended. How far is she from her starting point? So we're looking for this length here. Law of sines, law of cosine. Okay, law of cosine is correct. Can you tell us how you knew that?
There's a Z shape, so the 40 is on the other side of 15. So
Okay, I'll start with what he said first. Did everybody hear him? No, he said there's a Z shape. You can always make a Z shape with your north and south lines. It doesn't matter if one's going north and one's going south. North and south lines are always parallel, right? They're always vertical. And so he said that little 40 goes in here. Do you guys agree with him? Yes. Okay, so go on with what you were saying.
and then from there you just add the angles.
Add these two together,
Yeah.
and what do you get?
55.
55. Okay. And then you have this side, this angle, this side. Could you find the opposite side? Using law of cosines is what he said. Do you agree I can't use law of sines because there's no angle and matching side that we know? Shall we put letters? A, B, C. What side am I looking for? If this is X, is that side A, side B, or side C? So I'm going to start with B squared. A squared plus C squared minus what? 2AC cosine of angle. Is this a rearrange or not a rearrange? Not. B squared, that's our X. X squared equals, what is A in this picture? 45 squared. What is C? 30 squared minus 2 times 45 times 30 times cosine of angle what? 55. All right, go ahead and plug that in your calculator. Don't forget to square root. Yes. What was that? We don't do equations sheets second semester. It's only first because of the unit circles.
Yeah.
Because Taurus in this problem with the square root.
So
We have to square root everything. Yes. So the formulas don't roll over like they did in first semester, but on the final we need to study and have those readily available.
okay. So what we teach you and
Yeah.
just bring all up.
Yeah, and so when you get your test tomorrow, just write them down on the test. So these two formulas will not be up tomorrow, so make sure you get your test. As soon as you get your test, you write it down from memory so that you have it there and you're able to use either one depending on the information given.
Can you write all the formulas for you and look them on the board so we can study?
Law of sines and law of cosines.
Yeah.
Do you know them already? Do you,
I think I do know mine.
yeah. I'd hate to like
Okay, I think
make it feel overwhelming. Do you guys know your law of sines formula?
Sine of A over side of A.
Yeah.
And then sine is the side squared and then equals the opposite, the other two
For which one?
cosine.
Oh, this is it right here.
Oh, right, yeah.
Okay. So, anybody plug it in? What did you get? 30, 0 what? 99 paces. All right, next one. I'm going to have you go ahead and draw your picture for that one. I'll be right, please. Janelle, did you want to ask it out loud or do you want to? No, I was just going to ask if you were going to go over homework. Yes, after the dinner. All right, a hot air balloon rises vertically, standing 110 feet away from the launch point. Mrs. Torres notices the angle of elevation changes from 8 degrees to 48 degrees as the balloon rises. How far did the balloon rise? Did anybody draw the picture? Is anybody struggling with drawing the picture? Okay, can I give you guys a hint? Do you remember the problem I did in notes and we also did in homework where there was like a flag on top of the library? Do you remember that one? This is just like that. This is very similar to that type of problem. All right. Are we all ready? I'm going to move that up. That's too far down. Okay. Okay, yes.
Okay, it says the hot air balloon rises vertically. Oh, wait, no, just
Yeah, so it's not like, you know, going up at an angle. It's going straight up.
Oh, Miss Torres is wondering. I thought the balloon was. Like,
Well, oh, no.
Yeah.
Okay, so a hot air balloon rises vertically and then standing 110 feet away from the launch point. So this is the launch point. So I'm not 110 feet away from the balloon, which is up here somewhere. I'm from the launch point. I noticed the angle of elevation changes from 18 degrees to 48 degrees. So here's the balloon at a certain time of the day, and I look up, and what's the angle of elevation the first time? And then what does the balloon do over time? It rises. And when I look up the second time, what's the angle of elevation? Now, does 48 go in this little tiny angle or from the horizontal line? This whole angle here is the, what was it, 48 degrees. How far did the balloon rise? We are looking for from this balloon to that height, we're looking for this length right here. What type of triangle do I have? A right triangle, do you see that? I have two right triangles. I have the bigger one and then the smaller one. Yes? Do you see it? Does anybody remember what we did on this problem when we did it in notes and in homework? I'm looking for this height here. First off, do you agree I cannot work with this little triangle here?
Yeah.
I don't have enough information to use that little triangle. So how can I use the two right triangles, the smaller one and the bigger one, to find this height here? Louder? Find the what? This side? So find the height of both triangles? So this one, and then what do we do with them? Okay, she's saying subtract the two heights. So here's my big triangle. Here's my smaller triangle. We'll call this X and we'll call this Y. Do you agree if all of this is X and all of this is Y, if I take X and subtract the Y, I'd be left with the height the balloon moved? Yes or no? Yes? The total height, subtract the original smaller height, gives you the distance that it changed or moved. Okay, do they both have the same base of 110? 110 and 110. Now what's the angle for the larger triangle? What's this angle in here for the larger triangle? 48. What about the smaller one? 18. Now you can use SOHCAHTOA, or if you choose to, you can use law of sines. Do you guys have a preference?
What happens if like I found that line right there?
This line right here?
Yeah, I found that.
Uh-huh.
Then I found the upper angle
Uh-huh.
at the top, and I used law of sines.
You
Is that-
found this angle and
No,
that
the other
angle,
the other- yeah,
that angle,
uh-huh.
this
And then-
side.
Yeah, and then I used law of sines.
How did you find, oh, you did like,
Alternate interior angles plus 90.
what did you get as your answer?
I got 86.42.
Then yes. All right. So, can we use tangent here? Tangent of 48 equals what over what? X over 110. Tangent of 18 equals y over 110. Do you guys agree with that? Did anybody not use tangent? Did anybody use law of sines? Okay, quite a few of you. And is that perfectly okay? If you did law of sines, I'm assuming you found this angle up here? Yes? Can you guys tell me what that angle is? 32? 42. Now, if I did tangent or SOHCAHTOA, do I need to know that top angle? No, if you're doing law of sines, you would do sine of 42 over 110 equals sine of 48 over x. Do you agree? Sine of 42 over 110, and I don't know why I put a 42 over there. My apologies. Sine of 42 over 110 equals sine of 48 over x. And those of you that did it, the law of sines, what is this top angle in this one? Anyone have it? 72? Okay, and then you would do the same thing, sine of 18 over, sorry, sine of 72 is what I'll start with first, over 110 equals sine of 18 over y. Okay, how many of you did it this way over here with the SOHCAHTOA way? Any of you? Can you tell me what you got for x? 122.167. Those of you that did it this way, did you get the same or off just a smidge? Same? X equals 122.167. And what about for the y? 741. Did you guys get the same thing over here? Yes? All right, 35.741. And then what do you do with the two numbers? Subtract them, and what does that give you? 26 feet. Any questions? No questions? Yes. Were these two numbers the same? you didn't use the rounded ones? Is that what it was? Can you type this in your calculator right here, the 122, or I'm sorry, yeah, the 122.167 take away 35.741. Did you get it? Okay. All right, any other questions?